Hey guys, welcome back and welcome to semester 2. So we are on day 33 in algebra, and today we are beginning our unit on solving linear systems of equations. We're going to learn how to do it by graphing first. So first off, a system of equations consists of two or more equations with the same variables. This year in Algebra 1, we're just going to have two equations. Keep in mind you can have more than two. A solution to a system of equation is an ordered pair that satisfies both equations. So our answer that we're looking for is an ordered pair. There's three possible solutions though. If there's one solution, then you're going to have an ordered pair. Okay. If there's no solution, then it's that the two lines are parallel and they never intersect. And then there's infinite solutions so that the lines are the same. Okay. And I'm going to give you some examples for each. Okay, so the steps to solve by graphing. The first thing you want to do is graph both equations in the same coordinate plane. To simplify the graphing, you may want to write the equations in slope-intercept form, and I highly recommend you do that. Put it in the form of y is equal to mx plus b. That way you can identify your slope and your y-intercept. You're then going to estimate the coordinates of the point of intersection. So once you see where the two lines intersect, you're going to actually come up with the ordered pair. And then you're going to check them algebraically by substituting into each of the equations. So let's try some. Okay, so our first example, we have y equals x plus 1, y equals negative x plus 3. In both cases, we're already in slope-intercept form. So our slope is 1, in this case our y-intercept is 1. All right, so I'm going to start by graphing that first equation. Now, sometimes your systems of equations might have some brackets around them, but don't worry about that, okay? So we're going to start out, our y-intercept is 1, and our slope is 1. So you should be pretty good at graphing lines at this point, all right? If you're not, then you need to go back and make sure that you can graph lines. Okay, there's the first line. Now, the second line we're going to do will be the slope will be negative 1, and our y-intercept is 3. So we start at our y-intercept of 3, and we're going to go down 1. So right there, I can identify that we're going to intersect right at that point. So maybe I go over and I write that point down. It's 1, 2. Okay, now I'm going to keep making my line. Okay, there it is. All right, so that's my answer. That's my solution. I'm then going to take that solution and check it, all right? And I'm going to do that by taking that ordered pair 1, 2, and I'm going to plug it into both of these equations, okay? So I'm going to go back in and I'm going to say y is equal, so the first equation is y is equal to x plus 1. So I'm going to write 2 for my y is equal to 1 plus 1. Well, that works. 2 equals 2. So the first one works. Now I'm going to check it with the second equation, which is y is equal to negative x plus 3. So our y is 2, our x is 1, so negative 1 plus 3. And then we just check it. 2 is going to be equal to 2. That one works. So I know that 1, 2 is actually the intersecting point or the solution to that system of equations. All right, so I'm just going to keep going. All right, if you need to pause and try some, that would be great. All right, but I will just, for purposes of this video, just keep cruising along. Okay, but I highly recommend you stop and try some. Okay, number 2, my slope, it's already in slope-intercept form. My slope is 1. My y-intercept is 4, so I start at 4. Okay, my slope is 1, so I'm going to go up 1 and over. I'm going to start making my line here. All right, so there's my first line. All right, my second line, my slope is 2. So let's do that in a different color. All right, it's not taking it. Okay, it's not being nice. All right, there it is. My slope is 2. My y-intercept is 5. So I'm going to start at my y-intercept of 5. 1, 2, 3, 4, 5. And my slope is going to be 2. So we're going to go up 2 and over 1, or I can go down 2 and over 1. Oh, there it is. There's the point where I'm intersecting. So I'm going to note that. It's going to be negative 1, 3. Okay, I'm going to continue on though. I want to make my line. So I'm going to go down to over 1, so it's going to look like this. Okay, so my solution is right there, negative 1, 3. Then I do my check step. So y is equal to x plus 4. I'm just going to check it. So 3 is going to be equal to negative 1 plus 4. That works. 3 is equal to 3. Then I'm going to plug it into the second equation, my y is 3 is equal to 2 times -1 plus 5. 3 is equal to -2 plus 5, and that one works. 3 is 3. Okay, so I know that's my answer. All right, continuing on with number 3. All right, now we've got an example where we're not in slope-intercept form, so that's the first thing we want to do. -x plus 5. Okay, so I'm going to identify from here my slope, my y-intercept is 5. I'm just going to start graphing it. Okay, so my slope is -1. My y-intercept is 5. 1, 2, 3, 4, 5. There's my point. I'm going to go down 1 and over. Okay, all right, so we get our line. Okay, now the second one we're going to do, we've got in slope-intercept form, -2x plus 8. This is really important. You put it in that form. Your slope is -2. Your y-intercept is 8. So we're going to go up to 8, 6, 7, 8. And our slope is going to be -2. So we're going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. Okay, let's see. I'm kind of not lining up here. Let's see. I should be at, yep, actually we did. Okay, so right there is that point. So it's 3, 2. All right. Okay, we're going to go down 2 and over 1 again. So I'm going to draw my line. Okay, and there's my answer. The ordered pair 3, 2. Let's plug it in. Okay, to do our check step. Our y, which is 2, is equal to -3 plus 5. So that one will work. And then the second equation, we're going to plug it in. Our y is 2 is equal to -2 times 3 plus 8, or 2 is equal to -6 plus 8. So that one works. Okay. All right. Number 4, y is equal to x minus 7. So my y-intercept is going to be at -7. 1, 2, 3, 4, 5, 6, 7. And my slope is 1. So I'm going to start drawing my line here. Okay, so there's the line. All right, now the second one, we've got 4y is going to be equal to -x minus 8. When we divide by 4, okay, y is going to be equal to -1/4 x minus 2. Okay, so I'm going to start at my y-intercept of -2, and I'm going to go down 1 to the right 4. 1, 2, 3, 4. Oh, there's my point already. Go down 1 to the right 4. 1, 2, 3, 4. Okay, so I'm going to look at this ordered pair. It's at 1, 2, 3, 4, 1, 2, 3. So it's going to be at 4, -3. All right, so I want to check that. There's my second line. Always make your lines. I'll do my check step. When I check, I've got a -x, so -4, plus my -3 is my y. Does that equal -7? Yes, it does. So it works for the first one. Now I'm going to check it with the second one. My x is 4 plus 4 times -3. Does that equal -8? 4 minus 12 does equal -8, so we are good. Okay, couple more. All right, so looking at number 5, we put it into slope-intercept form. 3y is equal to 5x plus 3, and then we divide by 3. So our y is going to be equal to 5/3 x plus 1. Okay, so from here, I'm going to start at my y-intercept of 1. All right, and my slope is 5/3. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 3. There's my point, up 5. 1, 2, 3, 4, 5, and over 3. Okay, or I can go down 5, 1, 2, 3, 1, 2, 3, 4, 5, and over 3. Okay, so there's my line. All right, that's the first one. Okay, now the second one I'm actually going to do down here for some space purposes. So let's put it in slope-intercept form. 3y is going to be equal to -4x plus 30. And then I'm going to divide both sides by 3. So my y is going to be equal to -4/3 x plus 10. Okay, so I start at 10, which is right up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. right? And it's important that you're really accurate. We're going to go down 4 and over 3. 1, 2, 3, 4, and over 3. 1, 2, 3. There it is. I already have my intersecting point, which is going to be at 3. It's going to be, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6. Let me say 1, 2, 3, 4, 5, 6. So it's at 3, 6. Okay, so you got to be careful. All right, we draw a line. All right, so we think it's at 3, 6. Let's do the check step. So we get negative 5 times x, so negative 5 times 3 plus 3 times 6. Does that equal 3? Negative 15 plus 18 does equal 3. So we are good with the first one. All right, now looking at the second one, my 4 is going to be times 3 plus 3 times 6. Does that equal 30? 12 plus 18 does indeed equal 30. So we are good on the second one. So we know that that's the answer. All right, moving on to number 6. We're going to say negative y is equal to negative x plus 5. We're going to divide both sides by negative 1. So y is equal to x minus 5. Okay, when we graph that, our y-intercept's at negative 5. 1, 2, 3, 4, 5. And our slope is 1. So our line's going to look like this. All right, and just like the other one, I'm going to do it down here for space. Y is going to be equal to negative 3x plus 3. So our y-intercept is going to be at 3. 1, 2, 3. Oops, let's do a darker color. Come on. Okay, there it is. Y-intercept is 3. Our slope is negative 3. We're going to go down 3. 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. There's our point. Our intersecting point is going to be right here at 2, negative. It's at 2 and then negative 3. Okay, so we draw a line. All right, so we think this is our answer. Let's do the check step. X is 2 minus a negative 3. Does that equal 5? Yes, it does. It's 2 plus 3. So that works. And then the second one we'll check. 3 times x would be 3 times 2 plus a negative 3. Does that equal 3? 6 minus 3 equals 3. That one works too. So that works for both. So we know that that's our solution. Okay, so in those 6 examples, we had 2 lines with 1 intersecting point. Example number 7 is going to be a special case. Okay, so I want you to look at number 7. All right, the first one's already in slope-intercept form. So I'm going to just graph that. My y-intercept is 3. All right, my slope is going to be 2. So up 2 and over 1, up 2 and over 1. Okay, there's my slope. Okay, there we go. There's that line. All right, now the second one, I'm going to put it into slope-intercept form. So 2y is equal to 4x minus 8. And then when I divide both sides by 2, y is going to be equal to 2x minus 4. So my y-intercept's at negative 4. 1, 2, 3, 4. And again, my slope is 2. Now we learned last unit, when you have the same slope, you have parallel lines. Now we know if we have 2 parallel lines and they continue on and on forever, they're never going to intersect. Because they don't intersect, the answer is no solution. There's no place where they'll intersect. So there's no solution. Again, notice in both cases the slope is 2. Okay, and it has a different y-intercept. Because if it had the same y-intercept, then it would be the same line. And that's what we're going to show with number 8. Okay, so in number 8, I'm going to put it in slope-intercept form. So we got a negative y equals negative 3x minus 3. Then when I divide both sides by negative 1, I'm going to get y is equal to 3x plus 3. Okay, so I'm going to graph that. My y-intercept is 3. My slope is going to be 3. Okay, there it is. All right, I draw the line. Now the second equation, let's move down here to do this. I'm going to put it in slope-intercept form. All right, I just brought the 6x to the other side by subtracting. And now I'm going to divide everything by negative 2. All right, when we do that, y is equal to 3x plus 3. Notice we have the same equation. Okay, so when we graph that second one, it's going to be right on top of the first one, which means every single point is actually an intersecting point. So that's how we get what's called infinite solutions. There's an infinite number of solutions. means any x and y on that line would satisfy it. Okay, so there's infinite number. Okay, so now let's look at solutions. It says is 0, -2 a solution to the following system of equations? Well, this is like doing the check step. All right, all we do is plug in, okay, plug in the ordered pair. And if it's true for both, and this is important, true for both, then it is a solution. Okay, if it's false for either one, it's not a solution. Okay, so all I do is plug this in, 0, -2, remember my x and my y, so I get 0 minus 2 times -2 equals 4. 0 plus 4 equals 4, so that one works, that's true. And then the second one, -2 minus 0, does that equal -2? Yep, that one works too. Okay, so this one is a yes. All right, now the second one, when I plug in 2, 6, remember this is my x and this is my y, we get 6 is equal to 3 times 2 minus 3. 6 equals 6 minus 3. 6 does not equal 3. So that's going to be a no. We don't even have to do the second one, okay? So this one is not a solution. All right. And the final example that we have today is actually probably the easiest, okay? It says, what is the solution to the following system of equations? All you have to do here is look at the intersecting point. That's it, right there, and identify the ordered pair. It would be 1, 3. You don't need to figure out the equation of the line and do all the work. You just look at the graph and you see that it crosses at 1, 3. Okay, I hope this helped. Bye.